Hello and welcome to the Counterpoint podcast. I'm delighted to be joined today by Richard Windsor. Richard is a research director at large, as we call him, for Counterpoint, but also runs Radio Free Mobile. So, Richard, welcome to the podcast today. How are you?
Pleasure to be here, Peter. Fine, thank you. How are you?
Yeah, very well, very well. So, we're talking about a very interesting topic today, which is artificial intelligence and the impact that the COVID-19 pandemic is having on this um, broad topic. Um, AI has seen a huge amount of hype over the last few years, and I think companies, and you've written quite a bit about this, companies using the hype around AI to sort of drive their valuation, perhaps the egos of some of their directors as well. But um, I think you've maintained that a lot of what is labeled as AI is actually something else, and I think we'll get into that a bit during the discussion. But maybe as a sort of starting point, can we just broadly define what we mean by artificial intelligence? Because I think it's not just Siri, Alexa in your phone taking a good pick at night, is it? So how would you kind of characterize what AI really is?
Well, the AI, artificial intelligence, it's a very broad definition. It actually encompasses everything from statistical analysis to ordinary software to deep learning. That's the official definition of it. Um, the way people think about it is the advanced stuff where most of the improvements in machines' ability over the last 10 years have come from the technique of deep learning. And it is there where all of the hype basically is. Now, when we think about it, what we do is we separate it into two buckets, basically, which is proper AI companies that we call the practitioners and pretenders. Now, the difference between the two is very simple, is their AI today remains fundamentally limited in terms of what it can do. Companies that are trying to push back the boundary of what is possible with AI, we call the practitioners, and there's a relatively simple way that we define those. And those that base their intelligence much more on statistics, we call the pretenders. Now, the reason why it's important to tell the difference between the two is very simple, is a pretender using statistics is not creating a sustainable competitive advantage using AI. It's basically using the AI that exists to do something else. So let's say first mover advantage or a great brand or a great service. Whereas the practitioners are actually trying to do something different that makes their artificial intelligence better. And that's important. When you separate the two, it becomes quite clear very quickly that the ones in the practitioner category are going to be more valuable in the long term.
And would you have a view on of the companies claiming to be doing AI, how many sort of fall into each of those camps?
Yeah, it's surprising actually. So we actually have a third category, which is called the tricksters, and the tricksters basically are the ones that don't do any AI at all. And there was a study done about a year ago that surprised me greatly, which basically found that 40% of all companies in Europe that claimed to do AI didn't actually do any at all, be it statistics or the more advanced pushing back the boundaries area. When we then so you can take out 40% right away, the remaining 60%, of those 60%, probably less than 10% are the real practitioners, and the rest of them are using AI to make their products better.
Okay. So that gives us a pretty good setup. And I think it's probably also worth saying that, we've seen this sort of rise of artificial intelligence over the last few years. And, the way that I see it, at least, and correct me if I'm wrong, but it's been driven by, two factors that have come together. One is, the availability of huge data sets, enabled by the internet and everything that that's bringing with it. And the second is, increases in raw compute power. So when you kind of combine those two things, you get, the potential to do, a lot of what, we're going to talk about now, right? So, increases in things like machine vision or natural language understanding, and and how those are applied.
Yeah, that's exactly right. If you actually look at the technique that are currently in use today, these techniques were actually invented in about 1987 by a guy called Geoffrey Hinton. And the problem with them is that back then in 1987, there simply wasn't enough data and there simply wasn't enough compute power to make it all work, because it's very statistical in the way that it does work. And it wasn't until 2012, as you rightly point out, there was enough data and enough compute power to actually make it work. And that's when deep learning really started to produce some good results.
Now, the industry is, as we said, there's a huge amount of hype around AI, but I think you've been, on the somewhat more skeptical side, and you've been talking about, the potential to actually slip into another AI winter. And I think we've been through probably at least 2 AI winters over the last 30 or 40 years. There's this, great expectation that we're kind of moving towards this, scary future where we achieve artificial general intelligence, and then the world is destroyed by the machines. And then there's the more perhaps skeptical view, which is that artificial general intelligence is still science fiction and way off into the distant future somewhere. But we've got a pandemic, the COVID-19 pandemic, that's been raging around the world over the last 10 months or so. And you've written about how the pandemic is actually impacting in the development of AI. So can we talk about that a bit? So what is the impact right now?
Yeah, there are 2 things to unpack here. The first thing is, what is the impact of the pandemic on the ability of the industry to develop AI in the first place? And secondly, how has the pandemic itself actually changed the usability of algorithms that have already been created? So on the first hand, it's actually reasonably good news, which is most artificial intelligence is developed in the cloud. And so, most researchers have been able to carry on accessing the cloud from home just as well as they accessed it from the labs that they were working in before. So actually from that front, I haven't spoken to a single AI researcher who's basically said, I can't do my research anymore because I can't get access to the compute power that I was using before. So on that front, no real impact at all, I'm happy to say. On the other side, there is a significant possibility. And that is one of the problems or limitations that you have with artificial intelligence that uses deep learning is an algorithm created using deep learning cannot deal with when the circumstances change. And this is exactly what has happened in a number of environments. So take, for example, the travel environment. If you had an algorithm that was managing the capacity of your trains, for example, in terms of seats and passengers and so on and so forth, with social distancing, suddenly the rules of the game have changed. And it's when the rules of the game change that the deep learning-based artificial intelligence suddenly falls over. So in these kinds of scenarios, you're probably going to have to go out and retrain the algorithm again from scratch. And that could potentially cause some problem or setback. But, so far, the impact, I'm happy to say, it's actually been reasonably small.
Okay. And I think, if we follow that on, in your research, you talk about the 3 goals of AI. And I guess, the example you're talking about there with, having a data set around, controlling your trains is an example of, what would that be, sort of data transfer? So maybe you can kind of talk about the 3 goals a little bit and how each of those applies.
Almost all artificial intelligence, but people talk about today, they're talking about deep learning. Now, deep learning, while it has created some amazing abilities for machines, does have some fundamental limitations or drawbacks. And we've identified these, and we call them the 3 goals of artificial intelligence. That being, if you solve 1, 2, and 3, then you have a shot at getting to what people call artificial general intelligence, which is when the machines really start to become smart and you can actually have a proper conversation with a machine. What Alan Turing would have called passing the Turing test. The goals are, firstly, number one, is to reduce the amount of data that you need to create these algorithms. Right now, deep learning algorithms are very, very data hungry. You need to put massive amounts of data through them in order to be able to get a meaningful result. The other problem that we're also seeing at the moment is we are getting to the point where there's a diminishing law of returns, which means you keep pumping in more and more data. The incremental improvement is starting to get less and less. So goal number one is effectively, how can I redesign the system so that I need much less data in order to arrive at the same result, which would make it much cheaper and easier to make a deep learning algorithm.
So just putting that into sort of a simple context for me. So if I need to train the AI on its ability to identify a cat, maybe now I have to show it 100,000 pictures of cats before it can reliably tell the difference between a cat and a dog. So what you're talking about here is, maybe if I can only show it, 100 pictures of cats and dogs, and it's able to separate the two. Is that in very sort of simple terms?
Precisely. That is precisely what it is. And also, if you think about it from a human point of view, a 1-year-old child, you show him 10 pictures of a cat and he'll know any cat that he sees, whereas it takes hundreds of thousands to get a machine to do that. It tells you there is something missing in terms of how these machines are being trained. And that actually leads into the second goal of AI, which is the most fundamental of them all, which we call transfer learning. People call it artificial general intelligence. What it basically means is that when you train an algorithm to do one task, you can't take that learning and then apply it to another task. And let me give you a simple example of this. So when you do when a human learns to play Atari Brick Breaker, you quite quickly learn that the best strategy is to drill a hole through the wall and bounce the ball across the top. Now, that skill of hand-eye coordination, you could then take that skill and transfer it to another game, say Atari Defender. But a machine wouldn't be able to do that. What would happen is it would have to relearn all of that hand-eye coordination again from scratch. And the reason why this problem exists is because deep learning the machine does not understand the causal nature of the task that it is being asked to perform. So, for example, if you've got a vehicle, if you're in the road in a vehicle and the vehicle is being driven by a deep learning algorithm, that vehicle does not know that it's on the road. All it does is it separates statistical characteristics in order to arrive at the solution. And that is the fundamental problem. That is what creates a lot of the limitations around what artificial intelligence can do and what it can't do. It is why Siri and Alexa and Google are too fundamentally stupid. And if you ask them the question the wrong way around, they just don't get it because of this limitation. And progress in fixing this limitation is unbelievably slow, and it doesn't look like it's going to get fixed anytime soon.
Okay, and the third goal?
Third one is actually one where there is a little bit of progress being made today, which is what we call automated model building. So a lot of the algorithms that are created today, they have to be built and maintained and tuned by humans. And that is very expensive. It takes a lot of time. And so as a result of that, these systems are very expensive to train and create. And so if you can work out a way of getting the machines to build the models themselves, you can reduce significantly the time and cost to create artificial intelligence algorithms. So the way we think about real AI companies are trying to crack one or all of those three problems.
And so, in the reality that we have in 2020, where we have this pandemic, and as you've pointed out, the fact that a lot of work is being done from remotely or from home doesn't necessarily cause a big problem because people can use computers to get access to data sets and so on. But can AI help during this pandemic?
Yes and no. So again, the way to think about whether or not AI can help you do something is to think about or to imagine the data or the task that you're asking it to perform. So the way we think about it is very simple, is if the task that you're asking the AI to perform is finite and stable in nature, then it will work very well. If it is not, then it won't. Okay, and so let me put that into some degree of context. So let's take, for example, tuning base station antennas. So when at the moment, most base station antennas need to be retuned about once a month or so. And an engineer goes out to the base station, gets out a screwdriver, and he retunes the antenna. Now, the data set for that, which is the law of physics, is very stable and it's very well known. So that basically means that remote and dynamic tuning of base station antennas is an excellent task to ask the artificial intelligence algorithm to perform, because the data set never changes and it's very stable. And it's very finite because you're just governing, you're just looking at how the radio waves radiate and how they perform, and that's well known. If you take another task, such as autonomous driving, there's a completely different environment, because the roads there's almost an infinite amount of roads out there at the moment. And not only that, the situation changes all the time. From the point of view of, maybe the weather conditions change, or there's road works, or something's fallen across the road. So the data set for that complete. And this is why the autonomous driving companies have had so many problems trying to crack autonomous driving using deep learning.
Yeah, I mean, I think the autonomous driving situation is fascinating, and I guess relative to the pandemic, a number of the companies that have been pushing hard on autonomous driving have been those that stand to gain materially from cracking that problem, such as Uber, because paying the drivers is one of their biggest costs, or for Tesla, where they foresee being able to use the fleet of Teslas as robo taxis in some way. So I guess the nature of the pandemic and how that's causing people to have to sort of change the way in which they think about traveling around, or traveling less maybe, is going to alter the reality for those companies quite fundamentally.
Yeah, that's right. So if you take, for example, Uber has been incredibly fortunate with the pandemic that it also had Uber Eats. So if you actually look at Uber's financial performance now, Uber is no longer a ride-hailing company. It's a delivery company, simply because ride-hailing has fallen so much. Now, the problem is, of course, in the pandemic, robo-taxis would be great, because, a machine's not necessarily going to be able to infect you with the virus. The problem is that the technology is not even close to where it needs to be in order to make that both safe and viable from a commercial perspective. And in fact, back in 2017, when we first started looking at autonomous driving, we made the prediction that it would be 2028 before it is commercially available in a realistic way. And despite all of the changes that we've seen so far from the industry, we've seen absolutely no reason to change that estimate. And still 2028 looks about right in terms of when this technology will actually come to market in a commercial way.
Thanks, Richard. So moving the discussion along. So one of the companies that's seen a lot of interest and not a little hype is DeepMind, which has done great things in AI gaming. But I think you also see it as solving the quantity problem that you mentioned in the 3 goals. Can you expand on that a bit?
Yeah, certainly. So I have a lot of respect for DeepMind. And the company is genuinely trying to advance or push back against those 3 goals that we talked about earlier: data quantity problem, transfer learning and the automated model building problem. The issue I have with it is that DeepMind's marketing department is considerably better at pushing what DeepMind is capable of doing compared to what they've actually done. So they've made some pretty bold claims about how the company doesn't need data to create its algorithm, which is not really true. So let me tell you about, where they've arguably not done so well, and then somewhere where they've actually done really well. So in the first instances, they've made this claim about not really needing much data to make their algorithms. What they mean by that is they don't need to go out and gather huge amounts of data. The reason why DeepMind does its research on games is very simple. Go back to what we said about transfer learning. Transfer learning, and in deep learning works really well where the task is finite and stable. And the beauty about games is that games operate in an environment which is totally stable, which is 100% perfectly defined. So for deep learning, it's a perfect environment to actually create an algorithm that works. The second point about it is that games, by their very nature, when you play a game, you generate data that is perfectly labeled. You know exactly what it is. And so while they don't have to go out and gather data externally, because the way they work is that the machines are actually, or the different algorithms are actually playing against each other, they automatically generate massive amounts of perfectly labeled data. And so the fact they say, oh, we don't need data, it's very, very misleading, because they actually do use the same amount of data. In fact, regularly to train one of their algorithms, that they have to play 44 or 50 million games before they get to a decent level of performance. So the algorithm still consumes huge amounts of data. It's just that it's generating it itself. So that's one way where they've been a bit misleading. So, in another area where they have been, where they've actually made some real progress, I think, is on the automated model building problem. Problem number 3. If you remember, this is the fact that building neural nets and deep learning algorithms is an expensive, time-consuming, and manual process. What deep learning has actually done, DeepMind rather, what they've been able to do is actually incredibly impressive. They have created, this is something that they developed last year. It's an algorithm called Mu0. And basically what they can do with it, it's a completely generic algorithm. And you can basically take it and you can have it play against itself Go, chess, shogi, which is a Japanese version of chess, and 47 of the Atari games that were launched on the console back in the 70s and 80s. And with no customization, with no manual interference at all, the algorithm can train itself to play all of these games to a superhuman level of ability, which is actually very impressive, because what's happening in each of these instances is the machine is building the model by which it learns how to play the game, and it's doing it itself. Now that is a significant advance in our opinion, and that is somewhere DeepMind certainly I think has actually produced quite a lot of very interesting and possibly useful results.
But I guess still it's within the bounds of games, which, as you say, are they're stable and finite.
Exactly. And again, another area where they've been a little bit misleading is that they kind of give the impression, hey, we've got this one algorithm and it can play all of these games. Not quite true, because actually what you have to do, if you want to teach it to play 47 games, you have to take 47 copies of the algorithm, and each one of those is trained in isolation to play one game. And when you get to the end of the training, none of those algorithms can actually play any of the other games. So you're still very much in that transfer, in that limitation in terms of, I can't take what I've done in one task and apply it to another. There's no generality whatsoever, even though they would like us to believe that there is.
Okay, so we've been around this topic a bit. I mean, anything else you'd like to conclude here?
Yeah, I think a good way to finish up is that it's very easy to get the impression that we're very skeptical or negative on artificial intelligence, and I don't believe that is the case. The way we look at it is that actually artificial intelligence, even with the limitations that we've outlined, the 3 goals and so on, still has a lot of potential because there are lots and lots and lots of tasks where the data set is both finite and stable, where AI and deep learning in particular is going to be very, very good at solving, and it has not done so to date. And in some cases, so for example, in the medical industry, in terms of scanning biopsies, machines are actually better than doctors. And so from that perspective, there is a very bright future ahead for AI, and companies that utilize AI are likely to have a high return on investment. They're just not going to build flesh-eating robots that take over the world just yet.
All right. And on that encouraging point, let's wrap it up. So, Richard, thank you very much for joining us today.
Thank you very much, Peter.
And I would urge any listeners to sign up for Richard's daily blog at Radio Free Mobile. It's truly excellent. I'm an avid fan of it. So, yeah, thanks, Richard.
And anyone who wants to sign up, it's www.radiofreemobile.com.
There you go. Excellent. Thanks everyone for listening, and tune in next time for the next edition of the Counterpoint podcast. All right. Have a great day, everyone.